Hello guys, good afternoon. So this is Dr. Pooja and I'm going to talk about another interesting topic from your chemistry, and that is mole concept, right? By now you all know like how important is it to understand mole concept. Reason being, most of our reactions, most of our numerical problems that we get in chemistry, they are all from mole concept, most of it. Okay, so it is a very good idea to go ahead and understand what exactly is mole concept, and how do we solve numericals, how do we understand actually like what exactly is mole concept. Okay, so without wasting your time, let's go over it. And this is just the topic of today's session, mole concepts and atoms and molecules. That is the name of the chapter and it's from your chemistry. And before we get into more details of this, first of all, a little bit introduction about myself. My name is Dr. Pooja and I've done PhD in biotechnology. I was a scientist for 8 years, let's say in the United States, and now I'm back in India. And here I am an educator on Unacademy. I teach you guys physics, chemistry, and biology. If you have not signed up for our plus courses, this is the right time to go ahead and download Unacademy's app or on the website and sign up for the plus courses. You will know in a minute why do you need to sign up for the plus courses. Okay, and if you are signing up, here is the code that you can use. It's PS Live 10. That is my code, and you'll get 10% discount when you sign up using my code on the subscription. All right. So now let's get started, and I will at the end discuss about what are the different plans that we have for you guys so that you can learn in a better way with us. Okay, so before I get into the details of mole, like what exactly mole is, let's write down a small equation where we have hydrogen reacts with oxygen and it gives you water. Okay, and I'll just balance out this equation, right? So this is the equation that we have, and if we want to write, what would we write? We'll say two molecules. I'm going to the mole concept through this. Two molecules of hydrogen reacted with one molecule of oxygen to give us two molecules of water, right? So this is the way of saying this equation or writing this equation or explaining this equation. Another way is, we know that this is 4 atomic mass unit of hydrogen, right? How did we do it? 2 to the 4, and 1 atom of hydrogen is 1 AMU. We write it 1 AMU or 1 U. Okay, but if there are 4 of them, we'll multiply with 4 and this is what we get. Okay, 4 units, atomic mass units of hydrogen are combining with, let's do the same thing for oxygen, 32 atomic mass units of oxygen, okay, to give us, and what will be the total of this? The total will be 36 atomic mass unit of water. Okay guys, so these are the two ways of explaining how this reaction is taking place. We are talking about these reactions, how they takes place when we talk about chemistry. Okay, so in chemistry there are two ways of talking about these two equations. One, you talk in terms of how many molecules of or atoms of a particular element reacts with another one to give you a product. Okay, Or you can also talk about the same in their atomic mass unit, which means in their masses, their mass unit, how much the mass is. Okay? But if you look closely, at these, you will see the atomic masses of them, of these atoms, is somehow related to the number of atoms or the molecules. This is from where we have to use simpler terms in terms of numbers, which will be very simple to explain how many atoms or molecules of, let's say, hydrogen or oxygen reacted to give how many molecules of water. Okay, so that is one point that you have to consider. But as these atoms and molecules, they are very tiny, okay, and we cannot count them. Now, for example, now here I will take an example where I will talk about, let's say, for our day-to-day life, and if we say we want to talk about the numbers, the term we use is like, let's say, dozen. If we say 1 dozen of apples, there will be 12 apples. If we say 1 dozen of books, that means we're talking about 12 books. Or 1 dozen of, for example, pencils, so we are talking about 10 pencils, right? So 1 dozen in the physical world gives us something which is equivalent to 12 in number. Okay, so that is about dozen. But do you think when we talk about chemistry, right, we talk about very small units? We talk about atoms and molecules and ions, right? So these are the terms that we use. And do you think you can count these number to, let's say, a dozen of atom, which means 12 atoms or 12 molecules of oxygen or 12 atoms of hydrogen? No, right? Because they are very, 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 very tiny. They're very, very small. So we cannot use this dozen concept when it comes to our chemistry, atoms or molecules or ions or all these things, right? So there should be some number that we can use very comfortably and with very much confidence. Okay, so what do we have? That is where your mole concept come into the picture. Okay, so mole, technically mole means heap of something, which means heap of something. Okay, so 1 mole, if we say 1 mole is equal to, just like dozen is equal to 12, 1 mole is equal to 6.023 into 10 to the power 23 watt. Okay, just like dozen tells us 12. It does not matter what 12, it does not matter 12 atoms or molecules or books or what. Similarly, 1 mole is equal to 6.023, whatever it is, atoms, or 1 mole of molecules will be 6.023 molecules, so on and so forth, or ions, or whatever you have. Okay, whatever you want to have, 1 mole of atoms would be 6.023 atoms, or 1 mole of molecules or ions, that is what we have. Okay, so its mole is actually this number. And what do we call this number? We call it Avogadro's number. and it is represented by n naught. Okay, so n naught is the Avogadro's number, and here is the value for the same. All right, so now next what we have is, in case of dozen, hold on. Like in case of dozen, the number is 12, but their mass is not constant. Okay, so dozen is 12 of something and its mass is not constant. But when we talk about 1 mole, this is this is 1 mole, which is 6.023 of something, atoms and molecules, and here is the mass is constant. Okay, so now how much is the mass? That is important. So for example, we have water. The water is 36, right? Wait a second. Mm, 34. Right? Don't know. Okay. That is the 32, 34. Okay. AMU is the mass. So, which means if you take one molecule of water, that will be I'm sorry. Yeah, that's fine. So let's say here we have gives you 34, AMU. Okay, so which means when we have this 34 AMU, we can convert it to, for example, 34 grams. Okay, I'll take another example. For example, you have hydrogen. Now hydrogen is one atom of hydrogen is equal to 1 AMU. Okay, 1 atomic mass unit. Or if we convert this to grams, like 1 gram of hydrogen, that is equal to 1 mole of hydrogen. Okay, so this is what I wanted to explain to you. Just a second. Okay, so for example, we take example of oxygen. All right, so 1 atom of oxygen is equal to 16, right? (16 AMU), or we can write these 16 AMU is equal to 16 U, right? So this 16U is equivalent to 16 grams of oxygen. All right. So now that means this 16 grams of oxygen is equal to 6.023 into 10 to the power 23 atoms of oxygen. Okay, so that is the relationship between, this is the relationship which we all get confused between the U or AMU, okay, and grams and molecules or moles, molecules or atoms or whatever we are discussing here. Okay, so this was quickly about like how this mole concept, it works. So I'll just create a small table for you, for example, that will help you to understand it even better. For example, I write 1 mole of carbon. That means I'm talking about 112 grams of carbon, which is also equal to 6.023 into 10 to the power 23 atoms of carbon. If I take another example, let's say 1 mole of hydrogen atoms. That will be 1 gram of hydrogen atoms, or on the other hand we can say that this is equivalent to atoms of hydrogen. Okay, so this is the mole concept, and you will get multiple numericals from this. But before I recap, I would like to talk about few more things. So first of all, mole concept, or this Avogadro number, which is represented by N naught and which has the value of 6.023 into 10 to the power 23, whatever it is, atoms or molecules, right, or the things that we have. And this Avogadro's number is after the name of Amedeo Avogadro. Right, that is point number 1. Point number 2 is the mole concept that we have, Ostwald. The term mole was given by Ostwald. Don't get confused between these two for your MCQs. Okay, this is what you generally get, like who derived the term mole. So that is there. Okay, so now before I end this session, let's try a couple of numericals, because we still have some time. Okay, on mole concept. So guys, the majorly the numericals that you get from this concept is, in the problem it will say like how many molecules will be there in these many grams of an element or compound. They will mention the name of that. Okay, so for that, what you will have to do, you have to remember one formula, which is number of moles is equal to the given mass divided by molar mass. Okay, so this is what you have to remember. Number of moles is equal to given mass divided by molar mass. Okay, for example, if I take an example, so hold on. So let's take an example of the numerical. Let's say we have 52 grams of helium. Okay, so what you have to do is, for the 52 grams of helium, you need to find out the number of moles present. Okay, how many moles will be there? So now I gave you the formula. Number of moles is equal to given mass divided by molar mass. So the given mass here is 52 and the molar mass of helium, what is the molecular mass is, or atomic mass of something, is 4. Okay, that is the given mass 4. You divide 52 by 4 and the answer that you get is 13. So the number of moles that you have in 52 grams of helium is 13. Okay, so these are the 13 moles. Okay, now another one is, let's say they give you another example from this only, another numerical problem from this only, and that is second part of the numerical is, let's say there are 12.044 into 10 to the power 23 helium atoms are there. Finding mole, find out how many moles are there. So it is quite easy. So we know that the number of moles is given molecules or atoms or whatever is given divided by Avogadro number, which is N0. So here we have 12.044 into 10 to the power 23. You divide it by N0, which is 6.023 into 10 to the power 23, and what you get, the answer is 2. So which means number of moles is 2. Okay, so these are the kind of numericals that will be there from your this chapter. Okay, so now I will give you another problem to understand it even better. Okay, and that is, calculate the mass of the following. You have to calculate the mass of the following. So what do we have? We have 0.5 moles of N2 gas. Okay, so 0.5 moles of N2 gas, and you have to find out the mass. So we know that N is equal to number of moles given mass divided by molar mass. Correct? That is what I have shown you. So how do you do it? Given mass will be equal to, so if you have to calculate the mass of the following, that means we have to calculate the given mass will be equal to N into molar mass. So N is how much? 0.5 into the molar mass. Molar mass of nitrogen is N2 is, we know that because it says N2 gas. N2 is, how much is that? 28. Okay, because one nitrogen is 14, there are two of them, so 28 into 28. When you solve this, it will be 14 grams. Okay, that will be the given mass of N2 gas. And sometimes we get another numerical problem, 0.5 moles of N atoms. So here it was N2. What if we have to calculate 0.5 moles of N atoms? Same thing will do. Given mass is equal to N into molar mass or atomic mass in this case, which will be equal to N is 0.5, molar mass of nitrogen is 14, and the answer would be 7 grams. Right? And this is clear because here it is N2 and here it is N only. Okay? So this is all about, how we use mole concept in calculating our numerical problems. Just a second, it got stuck here. Okay. Now, if you have any questions, you can ask me or leave it in the comment section. And a quick recap of things I will do. 1, the mole is something which is equal to 60.023 into 10 raised to power 23, and this is also equivalent to the mass of, if these are in atoms or molecules or ions or whatever it is, it will be equivalent to mass of the atoms or the molecular mass and so on. Okay, so technically mole of something is equal to 0 to 3 numbers of the atoms, and it is equivalent to the gram atomic or molecular mass of that. Okay, so and also moles is equal to given mass divided by the molar mass. Okay, from here only we can solve any number of numericals which will be given to us. Okay, so that is it, guys, about the mole concept. And for more such interesting videos, for more such informative lectures, please go ahead and sign up on Unacademy's platform for plus courses, and don't forget to use my code there. And that's it for today. There is no homework to do, just solve some numericals. These are the subscription plans that we have for Unacademy Plus students. Okay, we have subscription from class 9 to class 12, and there are different live class for all subjects, and then weekly quizzes are there, doubt solving sessions, practice questions, and test series. Is that what we have? And apart from Plus, we do have iconic um, subscription options starting from 6 months up to 4 years. So go ahead and sign up, join us, and here we do have other things just apart from taking care of your academics. We have this critic corner where we have multiple things to make you guys a perfect personality, and you can subscribe, leave a comment for us, or hit the bell icon, get notified if you are looking for something really great. Okay, so go ahead and download the app, go ahead and sign up for our upcoming batches. Okay, so and this is the right time to sign up for Unacademy. Reason being, at this point, all the educators at Unacademy, they are launching their courses, they are launching their revision sessions, they're launching their question paper solving sessions. So go ahead and sign up for Unacademy for your plus course. All right, you guys have a wonderful time. Thank you so much, and with this I end this session. Leave your comments, and if you have any questions, do let us know, and we'll be more than happy to answer it. Okay, take care.